Unitree Robotics has officially announced the GD01, the world's first mass-produced manned mecha. This is not a concept study or a prototype. It represents a definitive shift in how we approach human-machine integration. But here is the critical reality check that the marketing materials do not tell you. The engineering leap required to safely operate a manned exoskeleton at a mass-market price point is so vast that it may fundamentally change the trajectory of the entire robotics industry. By the end of this analysis, you will understand exactly where the hype ends and the actual physics begins, and why this specific announcement signals a pivot in robotics talent that you need to know about. The immediate reaction to the GD01 announcement is excitement. The image of a human pilot controlling a powerful, transforming exoskeleton is the holy grail of industrial robotics. It promises a future where a single worker can lift heavy loads, navigate complex terrain, and operate machinery with superhuman strength. However, when we strip away the cinematic lighting and the dramatic announcements, the engineering documentation tells a different story. Unitree Robotics is a legitimate leader in the field. Their G1 humanoid robot, priced at $16,000, is a marvel of autonomous engineering. It can walk, run, and perform complex tasks using open-source software and simulation environments. But the GD01, the manned mecha, does not exist in their official technical records. There are no GitHub repositories for a GD01 control stack. There are no safety certification documents for a human-rated version of their current hardware. This absence of evidence is not a minor oversight. It suggests that the GD01 is either a conflation of existing models or a speculative concept that has been pushed forward before the underlying physics have been solved. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Here's the thing that separates the hobbyists from the professional engineers. We must distinguish between autonomous navigation and manned operation. The G1 robot operates on a planning horizon measured in seconds. It senses an obstacle, calculates a path, and adjusts its gait. If it falls, the software resets, the battery charges, and it tries again. The cost of failure is a software error. Now consider what happens when you put a human inside that same loop. A human pilot does not have the luxury of a second-long reaction time. If the robot's actuators lock up or the balance control fails, the pilot has milliseconds to react before gravity takes over. This requires a latency budget that is fundamentally different from autonomous systems. Current mass-market torque sensors and communication buses introduce delays that are too high for safe manned operation. The sub-100 millisecond response time required to prevent injury during a fall is a threshold that current mass production cost structures simply do not support. The transition from the G1's research-grade simulation environments to a physical manned vehicle exposes a massive gap known as sim-to-real. In a simulation, you can reset the physics engine instantly. In the real world, a failure during a transformation sequence or a sudden shift in center of mass results in catastrophic structural damage. The GD01's alleged transformable feature introduces a dynamic system where the center of mass shifts unpredictably. This is a non-linear control problem that is significantly harder to stabilize than the fixed-base G1 humanoid. Without extensive physical testing data, claiming mass production is a dangerous oversimplification. It implies a lower safety certification tier than traditional industrial automation, which is a risk that no responsible engineering team should take lightly. This brings us to the deeper implication for the industry. The announcement of the GD01, whether it is a real product or a bold vision, signals a massive pivot in the robotics talent market. For the last decade, the focus has been on algorithm development. We have poured resources into navigation stacks, vision transformers, and machine learning models that allow robots to see and move. But if we are serious about manned mecha, the primary engineering challenge shifts entirely. It moves from optimizing for speed and autonomy to designing redundant, fail-safe mechanical and electrical architectures. The engineer of the future will not just write code. They will design safety systems that can withstand the neuromuscular reflexes of a human operator. This is a shift from pure software to embedded safety systems engineering. The feasibility of a mass-produced, manned mecha hinges on solving the latency budget between the human's neuromuscular reflexes and the robot's control loop. Unlike the G1's AI navigation demos, which operate on seconds-long planning horizons, A pilot requires sub-100 millisecond actuation response to prevent injury during falls. This is a threshold where current mass-market torque sensors and communication buses likely introduce dangerous lag. The cost of failure shifts from a software reset to catastrophic structural damage, suggesting that mass production currently implies a lower safety certification tier than traditional industrial automation. So what does this mean for the industry if the GD01 is not yet a physical reality? It means the hype cycle is pushing the narrative forward faster than the physics can catch up. The allure of a manned exoskeleton is undeniable. It captures the imagination. But the engineering reality is that we are not there yet. The G1 robot is a triumph of autonomous design, but the leap to a manned vehicle requires a complete rethinking of safety, latency, and structural integrity. The GD01 may be a vision of where we are going, but it is not a product we can buy today. The real value for engineers is to recognize this shift. The talent market is moving from pure algorithm development to embedded safety systems engineering. The primary challenge is no longer just making the robot move, but making it safe enough to carry a human through the chaos of the real world. The knowledge gap here is not technical but factual. While Unitree is a leader in mass-producing unmanned robots, the leap to a mass-produced manned mecha remains unverified and likely speculative. The only verifiable engineering reality is the aggressive push toward lowering the cost of unmanned bipedal robotics through open-source SDKs and simulation environments. The GD01 serves as a powerful reminder that in robotics, the distance between a marketing demo and a commercially viable engineering breakthrough is measured in safety certifications, not just marketing budgets. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.